So we are starting with the subject of fluid mechanics, and when we talk about fluids, we need to understand that every fluid is differentiated from other fluid by virtue of things called properties. So what are those properties? So if you look into some, I would highlight the first. It's called density. How I define density? Technically, it is the ratio of the mass to the volume. So what actually I'm referring to is actually there is some body and it is having some mass, it is having some volume. So you can find the density of the body by taking the ratio of mass to the volume. Density is defined by the symbol rho, and as per the definition, rho is equal to mass upon volume. This mass in the subject will be denoted by small m and the volume will be denoted by V cross. You would be aware that mass is having a unit of kg and the volume is having a unit of meter cube. Hence, the unit of the density comes out to be kg per meter cube. Other important property which comes into significance is specific gravity. I can also call it unit weight, or I can also call it specific weight. Somewhere in strength of material, somewhere in geotechnical engineering, you will be using the synonymous terms. This is defined as the ratio of weight of a body to the volume. Now let's look how the formula goes. Specific gravity is denoted by the symbol gamma. This is gamma symbol, and this is given by weight upon volume. As you know, weight will be denoted by capital W and volume is denoted by V cross. Again, weight is a force unit, so this will be denoted by Newton and volume is denoted by cubic meter. Hence, the unit of specific gravity is Newton per cubic meter. I would like to tweak the formula of specific gravity here. We know that weight is equal to mass into gravity. That's a standard understanding. If I substitute it over there, so gamma is equal to mass into gravity upon volume. If I separate mass upon volume in a different bracket and gravity on the other side, so this can be written as rho into g and this is gamma. How has rho come? You can focus on your left hand side. So this is the relation between specific gravity and density. To get more clarity, let's solve a numerical. And before solving a numerical, we must understand that there are some specific units. So when you say that you have a unit, so if I talk about units of conversion, 1 ml, 1 milliliter is 1 cubic centimeter, and 1000 ml is equal to 1 liter, and 1000 liter is equal to 1 cubic meter. Now, if I give you a question, the question says that I go to a shop, and when I go to a shop, I get a bottle of oil, and the bottle of oil is of 1 liter. So the volume of oil is equal to 1 liter. That's the standard understanding, right? When you go to a shop, you buy the oil for 1 liter, and since there's a weight, you ask the person to give you the mass. So he finds that the mass of the oil is 900 gram. And now you're curious to find that what is the density of this liquid and what is the specific gravity. So when you want to find the density is mass upon volume. You know that mass is 900 grams, so when you want to convert it into kg, so you go 900 into 10 raised power minus 3, and this is kg. And when you want to convert liter to cubic meter, you know that 1 liter is equal to 10 raised power minus 3 cubic meter. So this cancels out and you get the density is equal to 900 kg per cubic meter. Now you're also interested to find the unit weight. So to find the unit weight, you know that gamma is equal to weight upon volume. Now there are two approaches. How the two approaches go, that either you can go with the formula of weight and you can write mass into gravity upon total volume, or you can go with the formula which we have created, that gamma is equal to rho into g. I would be solving it from both the forms. So mass is 900 into 10 raised power minus 3 kg. Acceleration due to gravity is 9.81 meter per second square, and over here your volume stands to be 10 raised power minus 3 cubic meter. So this comes out to be, well, you can calculate very easily. So this comes out to be 8829 Newton per meter cube. Same way, if you do it over here, you have found the density. Density is 900 kg per cubic meter into acceleration due to gravity. This would also come out to be 8829 Newton per cubic meter. You can also write it in kilonewton per cubic meter. So these both values can be written as 8.83 kilonewton per meter cube. So that's all.